Have you ever gone to the beach and made a sandcastle or dug a big hole and gone back the next day or even later that day and your castle is washed away, gone, or even maybe the water was really high when you first showed up and then later on the day it goes really low? Well, we call those tides. And tides have everything to do with where the moon is in the sky. So when I kayak, I know that my kayak isn't going to get stuck in low water if I see the moon is up high in the sky, because that moon is pulling the water and raising the water levels, creating a high tide. And when the moon is down near the horizon or to a right angle of me, I am going to be having a low tide. That is not fun kayaking, because then my kayak gets stuck on the bottom. So what exactly causes tides? All right, so before we get into that, we have to know that the moon's gravity is going to affect the tides more than the sun's gravity. And that has to do with one major reason. The sun is huge, but it's far away. The moon is pretty big. Not anything compared to the sun, but the moon is really, really close to us compared to the sun, which is why the moon's gravity affects us more. So another thing that we've really got to understand is that for every day, there are always two high tides. So that means the Earth always has two high tides on it. You're always going to have a high tide on the side facing the moon, and that's because the tides are actually going to be pulled by the moon's gravity. It actually lifts some of the water a little bit. Now, don't think that it's going to be this extreme. This is exaggerated. Tides are usually a difference of 5 feet on average. Some places it's like 40 feet, some places it's like a foot. But for average, it's like 5 feet, especially, you know, the Hudson Valley area. Our tides aren't crazy, crazy high and crazy, crazy low as they are in some other places. So we have one high tide that is going to be on the side wherever the moon is, but then we have another high tide on the opposite side of the Earth. What causes that? The Earth is, you know, the outer part of it is pretty much like it's a solid, right? So this side of the Earth is getting pulled, which pulls the back end of the Earth towards the moon a little bit, creating this huge area of a high tide. So we have one high tide on the side facing the moon, and then a high tide on the opposite side. And then we have low tides in these areas, and really just like this whole strip here. So where would our high tides be for this example? We would have a high tide that is right here underneath the moon, and we have another high tide on the opposite side of the moon. So this area here in the middle is not going to have a high tides. This is going to be our low tides, all right? So another thing, like I said, the sun influences tides just a little bit, but it does. So since the moon is always going to create a high tide on the side that it's on, and the opposite side, when the Earth, sun, and moon are in a line like this, or in a line like this, we're going to have our extreme tides, because not only is the moon pulling the tides in this direction, but the sun is using its gravity to pull the tides a little bit more. So we're going to have an extremely high tide here, an extremely high tide here, and then in the middle here, we are not going to have we're not going to have a high tide, we're going to have an extreme low tide. So when we have really, really high tides in some places, we have really, really low tides in another. I like to think of it as like 2 glasses of water. So if I have 2 glasses of water that are completely equal, and I want to make a really, really high tide in one of the glasses, I'm going to pour some of that water in, and now I'm going to have a water glass that's got really, really high water in it, and then the other glass is going to have really, really low water in it. So when we have really, really high tides in one spot, we have really, really low tides in another spot. And that is going to be when the moon and the Earth and the sun are in a line. In a line. Now, when they make a right angle, sun, Earth, moon makes a right angle, sun, Earth, moon makes a right angle. The moon is pulling this way, so we have a high tide on this side of the Earth, and we have a high tide on the other side of the Earth. But the sun is kind of pulling the tides this way and kind of pulling the tides this way. So they don't work together. So what's the main point here? When we have a new moon, when we have a new moon or the dark side of the moon is facing the earth, that's when we're going to have all of these in a line, and that's going to make it extreme. Forget about this moon. That's what's going to give us this extreme tide, where we have really, really high tides on the side facing the moon and on the other side of the earth, and then low tides on the sides that are 90 degrees to that. Main point. We have 2 high tides a day. So like, let's say if the moon is like right here, right? We're going to have a high tide here. So let's say we're starting here. If I turn the earth, it does 1 full rotation a day. This is a low tide. This is a high tide. That's our second high tide. This is a low tide. And we're back to our high tide. That is 1 full day. We have 2 high tides a day, 2 low tides a day. All right. So again, when the sun, moon, and the earth, or the sun, earth, and moon are in a line, they are working together to pull those tides, really, really high tides on the side facing the moon, and really, really high tide on the side opposite the moon, while we have the low tides at a right angle to those. When the sun, the earth, and the moon make a right angle, the moon is pulling in one direction while the sun is pulling in the opposite, right? And they don't really work together well to make those extreme high tides and extreme low tides, okay? So it's all about perspective. Which position would we have the extreme tides? If the sun is over here, remember the extreme tides, really high tides, really low tides, are when they're in a perfect line. So that'd be position 1 and 5. When would we have our non-extreme tides? That would be when the sun, the earth, and the moon make a right angle, right? So a right angle to the sun. So that would be 3 and 7 when we don't have our extreme tides. All right? So this is a tide graph. Always look down at the x-axis because we have time. And then this is going to be the height of the water. So the water goes high, and then it goes low, and then it goes high, and low, and high. So this is high tide and high tide. This is low tide and low tide. How much time goes by from high tide to high tide? Since we have 2 high tides a day, and there's 24 hours in a day, it's going to be 12 hours. Now, I could remember that, or I could figure it out. This time right here for this high tide is about 1 a.m. The next high tide is about 1:15, 1:30 p.m. So it went from 1 a.m. to 1 p.m. It's about a 12-hour difference. Technically, it's a little bit more, but for this class, we'll say a 12-hour difference. What time will the next high tide occur? This first high tide occurred at 1. This next tide occurred about at 1:15 or 1:30. So then that goes a.m. to p.m. And then we go back to a.m. for this next high tide. So it's going to be about a 1:30, 1:45 a.m. high tide for the next day. And then what is the height of the tide at 7 a.m.? These are just examples of Regents questions. Between 6 and 7 a.m., the height is negative 4.2 feet. All right? So that's the basics of tides. Main points. When the sun, earth, and moon are in a line, we're going to have our extreme tides because the gravity of both the moon and the sun are pulling in the same directions. When the moon, earth, and sun make a right angle here and here, we don't have our extreme tides. And the other thing you've got to know is that we have 2 high tides a day, we have 2 low tides a day, and every high tide is about 12 hours away from the next high tide.